word. All right, so we are finishing up the notes from last class. Last class we had intro to the unit circle. I think I called it part 1, and so we'll call this part 2. I'm not going to label it. It's just, we didn't finish it the first day, so I'm just going to put intro to the unit circle continue. And we're going to start with some directions. Find the coordinates of the point of intersection on a unit circle at a given point. Find the coordinates of the point of intersection on the unit circle at a given point. Example 1. So we're going to be drawing a lot of circles, okay? So I'm going to draw a unit circle, not giant, but I need to be able to see. And I'm going to draw the x-axis and the y-axis right through the middle. And I'm going to draw a 30-degree angle. My initial side is going to be the positive x-axis. And then the terminal side, I'm going to try and form a 30-degree angle with my initial side. So find the coordinates of the point of intersection on the unit circle at a given point, okay? So they want us to find the ordered pair, that ray that I just drew that intersected the circle. They want us to tell them, what's the ordered pair for that ray? So if this unit circle is on a graph, what would that ordered pair be, okay? And so we are using what we know about 30, 60, 90 triangles to help us figure this out. And you're like, well, I don't see a triangle because this side's rounded, right? That's not a triangle, that's rounded. Well, we did a little bit of this last class. What we're going to do to help us is we're going to create a 30, 60, 90 triangle by going to the point where our ray intersected the circle and drawing the line straight down to it's always to the x-axis so that it creates a 90-degree angle. Okay? So what would that other angle that I don't know, what would its measurement be? 60 degrees. Well, if I can figure out the length of this base, that will tell me my x-coordinate. And if I could figure out the length of this height, that will tell me my y-coordinate, right? Okay. Well, I know that 30, 60, 90 triangles have special relationships, right? And somebody tell me, what is the measurement of the hypotenuse in a unit circle? 1, because it's the length of the radius, correct? Okay. So I'm just going to kind of pick up this triangle and put it outside of the circle so I can make it a little bigger and do some mathematical computations. So right now I only know that the hypotenuse is 1. Relationships of the legs on 30, 60, 90 triangle. And what we learned last class. We learned that the smallest leg we will call side S, right? So the smallest leg is always across from the 30-degree leg. So that's your side S. We know that the hypotenuse is twice as long as the length of the small leg. So the hypotenuse is 2S. And we know that the leg across from the 60-degree angle is the small leg times the square root of 3. Okay, we only know the length of one leg, and sadly it's not the smallest leg because that would be much easier. We know the length of the hypotenuse, right? Well, so we could use that to help us figure out what S is. So I know that my hypotenuse is equal to 1. So if I take the 2S and set it equal to 1, that will help tell me what S is equal to. So what would S equal? Well, we're going to get fractions. If we divide both sides by 2, S will equal 1/2, right? So S is equal to 1/2. And if we know S, then we can find that leg across from a 60-degree angle because it's just S times the square root of 3. So in this case, that would be 1/2 times the square root of 3, and that's just the square root of 3 divided by 2. So the 2 is not under the radical. Only the 3 is under the radical. So the leg across from a 60-degree angle is the square root of 3 over 2. That's its length. Don't turn it into a decimal. Okay. The leg across from the 30-degree angle, our shortest leg, is 1/2. So our ordered pair, the x-coordinate, is the distance from the origin to the end of the base of the triangle. We learned that is square root of 3 over 2. So that's my x-coordinate. My y-coordinate is the distance from the origin to wherever this meets the y-axis. That would have the same length as the height of this triangle. So that is 1/2. And we did learn last class, although that seemed like forever ago, that in your first quadrant, your x coordinate is positive and your y coordinate is positive, right? So my answer, square root of 3 over 2, comma, 1/2. Yes? Find the coordinates of the intersection of the unit circle and a negative 60-degree angle. So my last angle, we were finding the coordinates when the terminal side intersect the unit circle at a 30-degree angle. It was positive. Remember I taught you that if you see a positive angle, that means that your terminal side started at the initial side and then it goes counterclockwise, right? So if this angle is negative, let's draw unit circle. When it's not very precise. The initial side always starts at 0 degrees. So if it was negative, counterclockwise, if I went 90 degrees down, this down here, although it's in my very inaccurate circle, that would be negative 90 degrees, right? And then what would this point over here be? Negative 180 degrees. And at the very top, I would be negative 270 degrees. And then if I made a full rotation going clockwise, if I made a full circle, I would end up back at negative 360. So before your terminal side moves, you're at 0. And then as it's rotating around the circle, it goes negative. Now, I probably should have done this on the last example too. So let's go back up to the top. We were dealing with positive angle measures, okay? So my initial side always starts at 0 degrees. And if your angle measures are positive, we're going counterclockwise. So our next, where the y-axis intersects the unit circle, the positive part, that would be positive 90 degrees. And then that straight line would be a positive 180 degrees. Add another 90 degrees onto that, you're at positive 270. One full rotation, and you're at 360 degrees. So 0 and 360 is in the same spot. It depends. Has your terminal side moved yet? If it's not, then it's at 0. If it moves all the way around the circle, it's at 360. Okay. Now, when I actually put the angle measures in the triangle, I'm not making them negative. You don't have a negative angle measure per se. Okay. It just tells you what direction that your terminal side is going in. So we're going to draw an angle for number 2 at negative 60 degrees. What quadrant do you think that would be in? Quadrant 4. If I said draw a positive 60-degree angle, what quadrant would that be in? 1. Okay, because that's going to go counterclockwise. So clockwise, negative, it's between 0 and negative 90. And we know halfway between would be 45. So it's going to be past that. So our theta is 60 degrees. A lot of kids get confused. Where do I draw the line? So go to the angle that we drew. You never draw a perpendicular line to the y-axis. It's always to the x-axis. Okay, so what's that other leg going to be? 30 degrees. So last time, our theta was 30 degrees. We saw the 30, 60, 90 triangle, okay, but the positioning is different. Our base is across from the 30-degree angle. Our height is across from the 60-degree angle. So let me take this on out of the triangle. We know the hypotenuse is 1, right? Is this going to have the same measurements as the last triangle? It's a 30, 60, 90, and the hypotenuse is 1, right? So if we set 1 equal to 2s, or 2s equal to 1, isn't s going to be 1/2? And isn't s the leg across from the 30-degree angle? And what's the length of the leg across from the 60-degree angle? Which would end up being square root of 3 over 2, right? So if your hypotenuse is not 1, you're going to get different measures. But in a unit circle, hypotenuse is always 1. So for a 30, 60, 90, hypotenuse is 1. The leg across from the 30-degree angle is always going to be 1/2. And the leg across from the 60-degree angle is always going to be the square root of 3 divided by 2. Your hypotenuse is not 1, you won't get those numbers. But in a unit circle, it's always 1. So, but we're going to get a different ordered pair because it's situated differently. So the leg across from the 30-degree angle is 1/2. We know the hypotenuse is 1. And then the leg across from the 60-degree angle is the square root of 3 over 2. Now remember, we're in quadrant 4. You're never going to find a negative measure of a leg. Distance of the leg of a triangle can be negative. However, in quadrant 4, or is your x going to be negative in quadrant 4? No. Is your y going to be negative? Yeah. So even though the triangle doesn't tell you that y is negative, y is negative. You have to know that. So what do you think my x coordinate is? 1/2, because that's the distance from the origin to the end of the triangle on the x-axis, right? What do you think my y coordinate is? Square root of 3 over 2. Your hypotenuse is never going to be your x coordinate or your y coordinate, okay? is going to be the base and the height of the triangle. So the ordered pair where the negative 60-degree angle intersects the circle is 1/2, comma, negative square root of 3 over 2. If you just put square root of 3 over 2, that's in a different spot. That's going to be in quadrant 2, quadrant 1. Quadrant 1, your x and your y are both positive. Quadrant 4, x is positive, y is negative. Coolio. Let's make a little note. Remember, in quadrant 4, the x coordinate is positive, and the y coordinate is negative. Coolio. Example 3. We may not have it as assignment today. We may finish notes today, assignment tomorrow. We'll see. We'll I know y'all will be bummed though if we don't have an assignment today, so I've really got to weigh it out. That was a joke. Find the coordinates of the point of intersection of the unit circle and a 45-degree angle. So 45 degrees, is that going to be clockwise or counterclockwise? Counter, because it's positive, right? What quadrant am I going to find that in? 1. And that would be halfway between 0 and 90 degrees, right? So that angle that I just drew is 45-degree angle. So if we go to the point of intersection, the ray I just drew, where it intersects the unit circle, and draw a line perpendicular to the x-axis, that makes a 90-degree angle that I just formed. That means I have a 45, 45, 90. Right on. What's the length of the hypotenuse? 1. Unit circle hypotenuse is always 1. Are my sides going to be 1/2 and square root of 3 over 2? No, those are 30, 60, 90. So we have to figure out what they're going to be. We know that a 45, 45, 90, since two angles are equal, the legs opposite of those two angles are equal, right? And if you recall, if the two legs, if we let S represent the two legs, what's the length of the hypotenuse? S times the square root of 2. Well, we only know the length of one of our legs, am I right? What's the leg that we know the length of? Hypotenuse. So we know that S square root of 2 is equal to 1. Well, knowing that little bit of information, we can solve for S, and then we'll figure out where other two side lengths are, right? So if you ever, like, I don't remember what the legs are, what's the legs, and 45, 90, 30, 60, 90 in a circle, then just do the math on it. But you would have to memorize the relationship, you know what I'm saying? You got to know something. So let me take that down here. S times the square root of 2 equals 1. I want to get S by itself, what would I do? Divide by the square root of 2. So square root of 2 divided by square root of 2 is 1. We just said it cancels. S equals 1 divided by the square root of 2. But remember, we can't leave radicals in the denominator of a fraction ever. Have we come across that this year? We have. Okay, I get confused because I also teach algebra 2, and I know we had an algebra 2. I can't remember if we had in pre-calculus. So do y'all remember how to get rid of a radical in the denominator? We square it if we're just trying to get rid of a radical. A radical in the denominator is going to be different. Nope. Well, you're kind of squaring it. Kind of. So what you're going to do is you're going to multiply by a new fraction. If you multiply by 1, does that change the meaning of the number? 5 times 1 is 5, right? 10 times 1 is 10. Okay. Well, what's 5 divided by 5? 1. So if I multiply by 5 divided by 5, I'm still multiplying by 1. Technically, it's still look different, right? Okay. What's the square root of 2 divided by the square root of 2? Which is 2, right? Would that get rid of a radical? But also, square root of 2 divided by the square root of 2 is equal to 1. Anything divided by itself. So if I multiply by a new fraction, it's going to be equivalent to 1, but it's not going to look like 1. It's going to be the square root of 2 divided by the square root of 2. Whatever that denominator is, make a new fraction, and the numerator and denominator will be the same as whatever the denominator is. We know when we multiply fractions, numerator times numerator. So what is 1 times the square root of 2? Square root of 2. Denominator times denominator. Square root of 2 times square root of 2 is square root of 4, and the square root of 4 is, do we now have a radical in the denominator? No, we multiply by the number 1. Actually, it was a number equivalent to the number 1, so that we didn't change the meaning, we just changed the way it looked. It's like 1/2 being equivalent to 4/8. They mean the same thing, they just look different. Okay? Can I reduce the 2's? No, because the square root of 2 is not equivalent to the number 2. So I now know that S equals the square root of 2 divided by 2. So both of my sides are square root of 2 divided by 2. So I'm going to bring that back into my unit circle. Guess what? Whenever you have a 45, 45, 90 in the unit circle, because the hypotenuse is 1, your legs are always going to be square root of 2 divided by 2 for both of them. Again, if this was not the unit circle and it was some other triangle that has a different length of the hypotenuse, then it's going to be different. But unit circle always has hypotenuse 1. So my ordered pair, we're in quadrant 1, so everything's positive. What's your x coordinate? Square root of 2 over 2, that's this little section right here. What's your y coordinate? Boom. Totally cool, right? I'm going to make myself a little note about this rationalizing. You cannot leave a radical in the denominator. So we rationalized the denominator to get rid of it. Okay. Example 4. Find the coordinates of the point of intersection. Of the unit circle. And a negative 30-degree angle. What quadrant is a negative 30-degree angle going to be in? Or, because we are rotating clockwise, a negative angle. So negative 30 is going to be in quadrant 4, somewhere between 0 and negative 90, closer to 0. But we don't label it negative 30. That's technically, an angle measure cannot be negative. It's just signifying the rotation. We are going to create a 90-degree angle from that point of intersection of the ray we just drew and the x-axis, and that creates a 30, 60, 90 triangle. In a 30, 60, 90, the leg across from the 30-degree angle is what? What? 1/2. The hypotenuse is 1, and the leg across from the 60-degree angle is square root of 3 over 2. We can redo the math again if you want to, but it's the same for any 30, 60, 90 triangle when the hypotenuse is 1. Leg across from the 30-degree angle is 1/2. Leg across from the 60-degree angle is square root of 3 over 2. Hypotenuse is 1. So remember, we are in the 4th quadrant. What's my x coordinate? Square root of 3 over 2. What's my y coordinate? Negative 1/2. I'm so impressed you said the negative. Now, do we only have angles in the 1st quadrant and the 4th quadrant? What about the 3rd and 4th quadrant? I got angles too, right? So let's check that out. Circle is kind of cool. I know I'm a nerdy math teacher, but I used to hate it because I don't remember doing any trig. We did SOHCAHTOA. That was it. I don't remember doing anything past that in high school or even college. So when I started teaching pre-calculus, actually even algebra 2, I had to teach myself all of the trig stuff. And so I didn't, first I didn't really know what I was talking about. I don't really know if I still know what I'm talking about, but enough to teach you what you need to know. So I used to hate it because I don't know, it didn't make sense to me. But now I'm like, now that I get it, I don't know why I was making it so difficult because unit circle is not really that difficult. I just wasn't familiar with it. But you know what I did? I watched YouTube videos until I figured it out. Like I tell y'all to do when you don't understand them. All right, I have 2 more examples. 5 and 6. Find the coordinates of the point of intersection of the unit circle and a negative 120-degree angle. Hey, there's no special right triangle that has a 120-degree angle in it. And anyway, can a right triangle have a 120-degree angle? No, it can't be over 90. Okay, so we'll see. What kind of rotation am I doing? Clockwise or counterclockwise? Clockwise. What quadrant do you think it's going to be in? You going to say 3? Okay, let's see. Draw a circle. X and Y axis. and I'm going clockwise. So if I start at 0 and go 90 degrees down, that's going to be negative 90 because it is clockwise, right? And then negative 180, negative 270, and one full circle, one full rotation would be negative 360. So you're telling me that negative 120 is in the third quadrant. Okay, I agree. So if we go from 0 to 90, how many degrees past 90 do we need to go to get to negative 120? 30 degrees past that. So I'm going to estimate about right here. So we started at 0 in our rotation. This is a 120 degree angle that we drew in. Well, I'm teaching you how to use special right triangles. Okay, there's no, like we said, 120 degree angle is not going to be found in a right triangle. You can't have any angle over 90 in a right triangle. Okay, well look, go to the point of intersection. Do not draw a perpendicular line to the y-axis. It's never to the y-axis. And even though I'm going to say that a million times, kids will still do it. Draw a perpendicular line to the x-axis. It's always the x-axis. Okay, so we're not actually using the angle that we drew, the 120 degree part of it. We're going to use the opposite side of it. So if it's 120 degrees from 0 to the ray that we drew, how many degrees is left for this angle here? 60. Because isn't a straight line 180 degrees? What do you call two angles added together that give you 180 degrees? Is it complementary or supplementary? I haven't taught you in a long time. I thought complementary is two that add together get 90. And supplementary is two that add together get 180. Anywho, I know this whole thing is a straight line, right? And then from here to here is 120. I got this has to be 60 to make that 180. That makes sense. Okay. So if that angle is 60, then this, we know we drew a 90 degree angle. What's the other angle going to be? 30. Okay. Well, we're still in a unit circle, so we still know the hypotenuse is 1, which means the leg across from the 30 degree angle is going to be what? 1/2. And the leg directly across from the 60 degree angle is square root of 3 over 2. Now, our ordered pair, like I said, your x and your y is never going to come from the hypotenuse. It's always from the 1/2 and square root of 3 over 2. It just depends on how it's situated. Remember, you're in the third quadrant. What's your x coordinate going to be? Boom. What's your y coordinate? Now we're good. So what that angle that we created, that is called a reference angle. So they asked us about a negative 120 degree angle, but we didn't use that angle, we used the other side of it. So that other side is called a reference angle. Our theta is the angle that was formed when the initial side is the positive x coordinate. We can't call that 60 degree angle our theta because it's initial side, it's not the it's the reference angle. Okay. So that's that. Let's do one more. Find the coordinates of the point of intersection of the unit circle and a 150 degree angle. I'm going to let y'all, can't see, I'm sorry. I'm going to let y'all get that one a whirl on your own. Oh, no, what'd you get? Negative 3 over 2? Negative square root of 3 over 2, comma 1/2. Anybody else get that? That's what I got too. Okay. So it's positive. So we know it's coming clockwise. What quadrant is it going to be in? Quadrant 2. So 150, we go 0 to 90, we're going to have to go 60 more degrees to get to a 150-degree angle. Right on? Are we going to be able to use that 150-degree angle for a special right triangle? No, we're going to use this other angle called the reference angle. And what would be the measure of our reference angle? 30. And then we drew in the 90, so the other one must be 60. We know the leg across from the 30-degree angle is 1/2, and the leg across from the 60-degree angle is the square root of 3 over 2, right? We are in quadrant 2, so x values in quadrant 2 are negative, so that's how we got the negative square root of 3 over 2. The y values in quadrant 2 are positive, so that's why y is positive 1/2. Okay, I lied. I said that I was just going to do number 6. We're going to do one more. Anybody have questions about that? Yes. It's the one we made. The new one, because 150-degree angle, that's not found in a 90-degree angle, a 90-degree triangle, right triangle. So we didn't use the 150-degree angle. We used the other side of it, the angle that was formed on the other side and the x-axis. Okay, that's what the reference angle is. All right, try this one. Find the coordinates of the point of intersection of the unit circle and a negative 135-degree angle. No idea. Ever, when I post the videos that I make, am I wasting my time doing that, or does anyone ever watch them? Okay, I see it. Kind of yeses. If it well, anyway, but they're here. But if you're absent, I know if you're here, you're probably not going to watch the video unless you're just really bored. But if you're absent, do you use the videos? Okay, so I'm not just wasting my time by posting videos. That's what I wanted to know. Thank you, Michaela and Yasmin. All right, we haven't answered yet. What do you have, Adam? So he said negative square root of 2 over 2, comma, negative square root of 2 over 2. Anybody else get that? That's what I got too. Good job. So it's a negative angle. So it is 135, negative 135 degrees. So we know we're going clockwise. What quadrant is that going to be in? Quadrant 3. So if we're at 0, we go to negative 90. That's going to be another 45 degrees to create the negative 135 degree angle, right? There are no right triangles with 135 degrees in them. So we can't use that angle, but we're going to use its reference angle, the other side. When we create that right triangle, what's going to be the measure of the angle that's formed with the x-axis? 45. Well, if I have a 90-degree angle and a 45, we know the other angle is 45 degrees. We also know that in a 45, 45, 90, the two legs are equal. The two angles are equal, the two legs opposite of them are equal. And we know since the hypotenuse is 1, we already know the measures of the legs, which are what? Square root of 2 over 2, both of them, right? Because we're in the third quadrant, the x's in the third quadrant are negative and the y's in the third quadrant are negative. So that's the reason it's negative square root of 2 over 2, comma, negative square root of 2 over 2. That's my answer. You want to do another one or you think you got it? You memorize what it for grade 16 it's 1/2 and square root of 3 over 2 and 45, 45, 9 square root of 2 over 2 and just know what's crossing what. Easy. All right, so anybody need any more examples? So we will have an assignment tomorrow. Today, we'll just finish these notes and good to go. So those of you at home, I'm going to go ahead and end the video so I can go ahead and get the video processing because it takes time. And then we'll see y'all back tomorrow. Have a good day. Remember, Thanksgiving is next week. We don't have school next week. Woo-hoo.
Hi, Miss.
Bye. Have a good day.
You too.
Thank you.
Have a great day, Miss Rayleigh.
You too. Thank you.